We're going to start this recording by looking at triangle PQR with that given information. So far all you know is the law of sines. So I'm wondering how we can use the law of sines to solve for Q. Of course, with the law of sines we need an angle matched up with a side across from it and another angle matched up with a side across from it. So as you try to set this up for a law of sines proportion, you're probably going to use angle Q because we're interested in side Q, and angle Q is the only one we know. But the problem is we don't have either angle P nor Q, nor can we solve for them because we only know one angle of the triangle. So if all we know is law of sines, we're stuck here. We need the law of cosines. So that's our job today. We're going to derive the law of cosines, then we're going to figure out how to use it to solve a triangle like triangle PQR. So I need you to get your companion sheet for law of cosines. We're going to try to do this derivation together. Okay, this is complicated. It looks very difficult, but that's one of the hard skills in math, is to be able to read through some math and make sense out of it line by line. Where does this line come from? How did it change? Can I make sense of the changes? Okay, so I'm going to ask you to try to read through this mathematics. Okay, where does this come from? From the diagram. Where does this line come from? From the diagram. And then in this triangle, where does this come from? Can I make sense of line by line? And then play the recording after you've had a chance. Really take the time to try to study it and make sense out of it for yourself. Okay, so first off, it's sort of broken out into sections. It says triangle ABD. That's this triangle right here in blue. Take a color and outline that triangle. Hopefully you can see that this is just the Pythagorean theorem for that triangle. Okay, this is just SOHCAHTOA. This is cosine of A equals adjacent x over hypotenuse C. And then I can multiply both sides by C and get rid of the fraction. Hang on to that, we're going to use that later. Now, next, let's look at this triangle. Triangle CBD. In this triangle, I'd like you to outline it with some other color. This side right here, we've split up the whole B side into an x part and a b minus x part, the part that's left. So when I use the Pythagorean theorem, I have to expand out the b minus x squared, and of course that becomes b squared minus 2bx plus x squared. Now we're ready to combine the stuff we know so far. Okay. We're going to substitute in place of this x squared plus h squared, we're going to substitute something that's equal to it. C squared is equal to x squared plus h squared, so in place of that we're going to put in a c squared. Okay. Next, in place of x is equal to c cosine A. I'm going to substitute in place of x c cosine A. And hopefully you can see that this second to last line is the same as the last line. We've just reordered the terms. I took the c squared and put it in the middle. There's your law of cosines right there. And that's found on your reference sheet. Not something you need to memorize, but it is a formula that you need to make sense out of, and I want to go through several versions of it right now. Okay? I want you to notice that angle A, capital A, is the only angle in the cosine formula, and little side a is the side that's over here on its own. Notice how sides B and C, the other two sides, are interchangeable, right? When we add, the order doesn't matter. And here we're multiplying them, the order doesn't matter. So it's just a matter of getting that one side in the right place. Okay? So I want you on your paper to write down what would be the version of the formula using triangle ABC if I knew angle B. Okay? So hopefully you realize that angle B would be the one over here on its own. And if angle B is the angle, little side b has to be the side that's off on its own. And A and C are interchangeable, so it's a squared plus c squared minus 2ac, the other two sides. Hopefully you're catching on with this. Write another version of the law of cosines where angle C is the angle that's involved. Okay, and then play the recording. So hopefully you wrote something like this. Angle C is the angle involved. Therefore, side C is the one that's by itself. Those guys match up. A squared and B squared, A and B. Finally, let's not even use A, B, and C's. Let's forget that altogether and involve a triangle where we have sides M, N, and P. So angle P is off by its own. I want you to write down a version of the law of cosines involving M, N, and P. All right, so hopefully you ended up with angle P is the angle involved, so therefore little side P is off by its own. P squared equals M squared plus N squared minus 2mn cosine P. Now that you've seen where the law of cosines come from, in our next video we're going to apply the law of cosines to solve for angles and sides of triangles.